Hello, my name is Ferenc Murányi. I'm product manager for weighing components at METTLER Toledo. Having confidence in your weighing system for your production batches is critical to ensure high quality products. Downtime is not an option. Right at first time batches are a must in the chemical industry. Our PowerCell technology and the diagnostic functions help to avoid errors or inaccuracies which could potentially lead to poor product quality or, in the worst case, recalls and claims. Let me demonstrate the key functionalities of our PowerCell technology with this demo tank. At the bottom, we mounted traditional old-school analog load cells. On the top, we mounted our PowerCell technology. You might ask, what are the key differences between analog systems and our PowerCell technology? There are many, but today I will cover the top 5. The first 4 functions alert you about the following conditions: missing or failing load cell, out of range temperature, overload of a single load cell, and a symmetry error. If any of these events occur, we have the 5th function in our PowerCell technology, the run flat. That will make sure that your weighing system is running even in the case of error. Firstly, I will demonstrate how the system alerts you about a missing or malfunctioning load cell. Of course, we assume everything runs as intended, but remember, it takes only one failure to result in irreversible consequences of a production batch. In an analog system, the weighing terminal receives the sum of the signals coming from the load cells without any further information about the status of the scale. But in a PowerCell system, each load cell transmits the weighing result and the status information. In contrast to PowerCell system, in an analog system, the component failure is not apparent to the operator or to the control system, which could lead to out-of-spec results. Using PowerCell technology, this won't happen. Let me now demonstrate what happens when a load cell completely fails. To show that, I will cut the cable of an analog load cell and of a PowerCell load cell, and we will see how the system is affected. On the terminal's display, you see the analog weight value at the bottom and the PowerCell value on the top. Now I cut the analog cable. You see a significant change in the indicated weight, but you can't tell if this value is true or not. So a broken load cell goes completely undetected. Now I'm cutting the PowerCell cable, and you see a totally different result displayed on the terminal. In this case, the user and the control system are alarmed and they can react before any real problems occur. Each PowerCell contains a temperature sensor which detects when the temperature is out of range. For example, if exceptionally hot material is in the tank or nearby, you are immediately alerted about potential measurement errors. Each PowerCell load cell also self-monitors to tell you when the load is too heavy or has a run-in with heavy equipment. This self-monitoring tells you about potential reduction in accuracy and, in the worst case, damage of the load cell or components within the scale. PowerCell load cells constantly monitor themselves for internal defects, such as broken wires, leakage, and sufficient voltage supply. If anything is amiss, you will receive an alarm to prevent costly production errors. In a tank scale, the center of gravity typically stays in a small horizontal range and mostly shifts vertically with loading. Let's assume material slowly collects on one side, leading to negative consequences in your production. This collection of material shifts the center of gravity one side and is detected by the terminal as an error condition. The same would happen when a tank leg breaks, the foundation loosens, or a blockage develops. Thus, symmetry monitoring is a form of condition monitoring that lets you react before trouble gets there first. Again, this is not possible with an analog system. We have talked about the condition monitoring that a PowerCell-based system delivers. If you see a rare failure of a PowerCell scale, you have the option to stop production or use the automatic run flat function. Similar to car tires, run flat allows you to drive slowly until the tire can be replaced in the next repair shop. The terminal emulates the faulty load cell, so manufacturing can continue, with a lower accuracy of course. That ensures a smooth transition until the problem is solved. Now I cut the PowerCell load cell cable again, and then you see a much better outcome. The run flat function is activated, so the terminal continues weighing, including a clear status indication that it is in a less accurate state. Again, this safety feature is not available in analog systems. All the PowerCell functions help to avoid undetected failures that lead to production problems and even to product recalls. So when quality is important and uptime is important, consider our PowerMount weigh modules with the built-in PowerCell technology. And now, the clear winner is PowerCell.